Question 5. Given that a function f maps real numbers to real numbers. So f of x there is what we call a piecewise function. So it's one function into three pieces. The first piece for when x is less than 6, second piece 7 when x equal to 6, and the final piece, third piece, x plus b when the domain x is greater than 6. Find the values of the constants a and b if the limit of f of x as x approaches 6 exists. Okay, so if it exists, it means the left hand limit. So if it exists, the limit. So if f of x exists, it means that the left hand limit is equal to the right hand limit. The left hand limit is equal to what we call the right hand limit. And of course, both of them should be equal to when f of x, both of them should be equal to the limit of f of x as x approaches 6. So for the top one, so if we can equate both each of them. So whilst replacing x with 6, so for the first, we can equate the first two. So the first two replacing x of 5x minus a, so we can equate 5x minus a to 7, and we can equate the last two, which is we can equate also x plus b also to 7. Alright, so we can equate them, and of course replacing x with 6, alright, in each of them. So if x replace for the top one, replace x with 6, we end up with 5 times 6, 30. So we end up with 30 minus a is equal to 7. And if we do some rearranging there, a would be equal to 30 minus 7. So 30 minus 7 is equal to a. So a will be 23. And for the second one, so this was for the first one. For the second one, replace x with 6. So then with 6 plus b is equal to 7. If we subtract 6 from both sides, b is equal to 1. So a is 23 and b is 1. Next, determine all the points of discontinuity of the function f of x, defined by f of x is x squared minus 9 upon x squared minus 4x minus 45. So of course it's discontinuous when, remember we can't divide by 0. So discontinuous, so the function is discontinuous. So discontinuous when the denominator is 0. So when x squared minus 4x minus 45 is equal to 0. And of course, you could factorize. How can we factorize this now? We could use x minus 9, x plus 5. Alright, so these would be the two factors if we should factorize this. Or we could use a quadratic formula and to solve, equate both brackets to 0. So x equal to 9 or x is equal to minus 5. So the function is discontinuous when x is 9 and when x is negative 5. Because when x is 9, you'll end up with a denominator of 0, which is undefined. Likewise, when x is minus 5, the denominator 0 divided by 0 is undefined. So you won't get a corresponding y value when the x value is 9 or when the x value is negative 5. In other words, the function is discontinuous at those points, as those x values. Differentiate the function with respect to x. Let me just rewrite y. E to the 7x plus x plus 4, root x plus 4 is same as x plus 4 to the half. So dy by dx differentiating exponential function, we differentiate the power, differentiate 7x, we get 7, and then we just put back the exponential function there. Alright, we're using the what we call chain rule, which says multiply by the power, subtract 1 from the power. So half minus 1, that's negative half. And then we differentiate what's inside the bracket. Differentiate what's inside the bracket. Differentiate x, you get 1. Differentiate 4, you end up with 0. So that's just 1. So that's that. Part D, given that dy by dx, given that y is equal to 2 minus 3 cos x over sin x, show that dy by dx is equal to that. So differentiating this, we'll use, of course, the quotient rule. So dy by dx, let's use the quotient rule. So the quotient rule says differentiate first the numerator. So we're going to differentiate numerator first. Differentiate 2, you get 0. Differentiate minus 3 cos x. Differentiate minus 3 cos x, you get positive 3 sin x. And we multiply by the denominator. Minus, then we alternate now. So we're going to differentiate sin x, you get cos x. And you multiply by the numerator. All over the square of the denominator. Alright, let's simplify the numerator now. So this is sin x times sin x, that's 3 sin square x. Let's distribute in negative cos x, so we have negative cos x times 2. That's negative 2 cos x. And negative cos x times negative 3 cos x. That's positive 3 cos square x. All over the denominator, which is sin square x. Let's continue. So notice we have 3 sin square and 3 cos square. Alright, so we're going to put the sin square and the cos square together. So we have 3 sin square and 3 cos square. So we have 3 sin square x plus 3 cos square x minus 2 cos x over sin square x. Continuing, we can factor 3 sin square, 3 cos square, so it's 3 cos square. So we can factor 3. So factor out 3, we end up with 3 sin square x plus cos square x minus 2 cos x over sin square x. And remember that sin square x plus cos square x is equal to 1. So sin square x plus cos square x is equal to 1. So that's just 3 minus 2 cos x. So remember that. So minus 2 cos x over sin square x, which is exactly what we're asked to show. Now we're asked to find dy by dx when x is equal to 45 degrees or pi over 4 radians. So we're going to, so dy by dx, so now we're going to replace cos the x with pi over 4, so it's 3 minus 2 cos pi over 4 over sin pi over 4 all square. Alright, so this is 3 minus cos pi over 4. So remember pi over 4, that's 45 degrees. So it's 3 minus 2. Now cos 45 is root 2 over 2. So it's 2 times root 2 over 2 over sin 45 is also root 2 over 2. So root 2 over 2 all square. So this becomes now 3 minus 2 times root 2 over 2, that's also minus root 2, divide by root 2 over 2 all square, which would be 2 over 4. So dividing by 2 over 4, which is same as half. So dividing by half is same as multiplying by 2, right? So all over 2. So we end up, this becomes 6 minus 2 root 2 when we expand that bracket there. A stone is thrown vertically upwards from level ground. The equation of the motion is S equal to 29.4 t minus 4.9 t squared, where S is the height in meters and where S is the height in meters and t is the time in seconds. Using differentiation, find the maximum height reached by the stone. So the maximum height reached, so the maximum height. The maximum height is when ds by dt is equal to 0. Alright, so differentiate s with respect to t, so that's 29.4. Differentiate the next term, that's 2 times 4.9, that's 9.8. Subtract 1 from the power t, equate that to 0 and solve. So if we equate it to 0 and solve, so we would have 29.4 equal 9.8 t. Divide both sides by 9.8. Alright, so end up with t equal to 29.4 divide 9.8. So we get 3. So the maximum height occurs after, it's reached after 3 seconds. So remember S is equal to, this is S, so to get the maximum height, we substitute. So the maximum height, we substitute 3 for the t, so it's 29.4 times 3 minus 4.9 times 3 square. Alright, because the maximum height is after 3 seconds. Alright, so to get the height, replace t with 3, so we end up with the maximum height. 29, let's work this out. We end up with 29.4 times 3. So I'm using a calculator and do everything. So 29.4 times 3 minus 4.9 times 3 squared. 3 squared is 9. So 4.9 times 9. That's 44.1. 44.1. And it's meters, right? 44.1 meters. Find the rate of change of the area of a square whose size changes at a rate of 7 centimeters per second when the length of each side is 21 centimeters, right? So we have a square. We have a square. Length of each side is 21. Alright, so we want the area of a square. So remember the area of a square. Area of a square is, I'm going to call one of the side x. So the area of a square is x squared, where x is the length of one of the sides, right? Yeah. What are we asked to find now? Find the rate of change of the area of a square whose sides, okay, so we want this rate, the rate of change of the area of a square. So rate of change of the area is actually dA by dt. So we can form an equation. dA by dt is actually dA by dx times dx by dt. Alright? So notice this denominator is the same as this numerator. We are left with dA by dt. Alright? So dA by dx. Now dA by dx would differentiate a equal x squared. So dA by dx would be just 2x times dx by dt. Remember, x represents the side. So dx by dt is the rate of change of a side. And the rate of change of a side is 7 centimeters per second. So it's dx by dt. Alright, is the rate of change of the side. Alright, which is 7. Right, so this would be 7 times 2x, that's 14x. And we are told that the length of each side, we want to find it when the length of each side is 21. Remember, x represents the length of a side, so we can replace x with 21. So it's become 14 times 21. And 14 times 21 is 294. So 294. Remember, it's rate of change of area. The units for area, square centimeters per second. Question 6. Determine each of the following indefinite integrals. So integrate 1/3, end up with 1/3 x. Integrate 2x plus 1 all square. We can use the reverse chain rule. So 2x plus 1, we add 1 to the power. We get 3, divide by the new power, which is also 3, and divide by the derivative of what's in the bracket. That's 2. So this is 1/3 x plus 2x plus 1 to the power of 3 over 6 plus constant. Another approach you could have taken is just expand the bracket, expand this bracket, and integrate each term individually. Alright, next. Alright, we can use log. So this is ln log 3 minus 2x. But notice if you differentiate this, you'll end up with a minus 2, with a minus 2 there. So the integral here just would be -1/2. ln 3 minus 2x. Partial derivative, so the partial z by x. So this time we're going to differentiate with respect to x. So we're going to treat everything else as a constant. So partial z by partial x, differentiate 2, differentiate any constant to get 0, differentiate minus x. Remember it's minus 1x, so differentiate minus 1x as minus 1. Differentiate y squared, remember we're treating the y as a constant, so that's also 0. Differentiate negative cos xy, alright, so remember the coefficient here will be the y, alright, so actually positive y sine xy. Partial z by partial y. This time now we're going to treat the x as a constant and the y as a variable. So differentiate 2 or any constant, we get 0. Differentiate x or any constant, we get 0. Differentiate negative y squared, multiply by the power, subtract 1 from the power, so that's negative 2y. And then differentiate the cos term. Remember, differentiate cos is negative, so negative, negative, that's how we get the positive, same up here. That's plus, and sine, angle remain the same. But this time now the coefficient is, since the variable is y, the coefficient now is the x. Alright, so we'll put the x at the front here. Next, figure 5, not drawn to scale, shows a line f of x equal to x plus 5, and the curve g of x squared plus 2x plus 1, intersecting at points A and B. Alright, so show that the coordinates of the points A and B are negative 2, 1 and 2, 9. So of course, we need to equate these functions. So since both of them are equal to y, so we equate them. So we solve them simultaneously. So x squared plus 2x plus 1 equal to x plus 5. Alright, since both of them are equal to y, both of them are equal to each other. So we have a quadratic. So if we subtract 2x from both sides, we end up with, let's group the like terms. So we end up with x squared, 2x minus 2x, that's 0. 1 minus 5, that's negative 4. Alright, so it's same as same as x squared is at 0. Or we could say x squared equal to 4. Alright, which means x is equal to 2 or x is equal to negative 2. Since 2 squared gives you 4, but you square negative 2, you also get 4. So those are the, notice, alright, x values, one is 2, one is negative 2. Now to get the y value, so the y value, and to get the y value, you can plug the x value into either this or this. It doesn't make a difference. You still get the same y value. If you put the x here, for 2, x is 2, 2 times 2, 4, 4 plus 5, 9. Alright, so hence 2, 9. Or if you put the 2 here, what you'll have is 2 squared plus 2 times 2 plus 1. That will also give you 9. Alright, and then the other y value, you sub the other x value, which is negative 2. So 2 times minus 2, that's minus 4, plus 5, that's positive 1. So negative 2, 1. Or you could have sub the negative 2 here, negative 2 squared plus 2 times negative 2 plus 1 would also give you 1. Alright, so here the values are 2, 9 and negative 2, 1. So I imagine the positive 2 would be here. Well, the negative 2 would be here. What were the x values again? X values were negative 2 and positive 2. Alright, and the positive 2 would be here. So use integration to find the area of the shape enclosed by the curve g of x and f of x. So the area would be the integral between negative 2 and 2. These are the x limits, and the function or function where the line 2x plus 5, x squared plus 2x plus 1 for the curve. So 2x plus 5 minus x squared plus 2x plus 1 with respect to x. So this should give us the area. Alright, let's so this is actually, so a is the integral between minus 2 and 2. This is, so if we should, well, we did the subtraction already, right? This is 2x plus 5. So 2x, and this would cancel. This would be expanded with negative 2x. That would cancel. Alright, and so you have 5 minus 1. So when you simplify this, you end up with 5 minus 1, which is 4, minus x squared. Because positive 2x will cancel. When you expand here, you get actually negative 2x and negative 1. So 5, so that will be that. Alright, if we integrate this, we'll end up with, now integrate 4, we get 4x. Integrate x squared, we get x cubed over 3. And the limits here are 2 and the minus 2, right? 2 and minus 2. So how we calculate this? In one bracket, we replace x with 2. In the other bracket, we replace x with negative 2. So the first bracket, we're going to replace x with 2. So 4 times 2, that's 8. Minus 2 cubed, that's 8 over 3. The second bracket, we're replacing x with minus 2. So 4 times minus 2, that's minus 8. Replacing the x with negative 2, you're going to end up with negative 8. So that's positive 8 over 3. Right? And if we simplify this, 8 and this will be positive 16. Positive 16. And minus, so with 16 minus 16 over 3, that should give us what? 10 and 2/3, right? Square units, since it's talking about area. By separating the variables, solve the differential equation, and we have the differential equation there. Let's solve this differential equation. So by separating the variables, what can we do? Can we expand? If we expand, we end up with x times y, that's xy, minus x times x dy by dx, so minus x squared dy by dx equal to y. We can do some grouping now. Let me just do some rearranging here. So I'm going to bring this y here. So I'm going to have xy minus y and bring over this dy by dx term equal to x squared dy by dx. What we could do here now is factor out the y. So we factor out the y, would have, this is 1y, right? So we end up with x minus 1 equal x squared dy by dx. And we could now divide both sides by, what can we do? We can multiply both sides by dy by dx. I will just cross multiply. We can times both sides by dy by dx, sorry. So we can times both sides by dx. So that into that. So we have here x squared dy. Over here, we'll have y into x minus 1 dx. So we have y into x minus 1. Put the dx here. And we can now divide both sides by, we want the x terms by themselves and the y terms by themselves. So we can divide both sides by x squared y. So divide this by x squared y. Divide this by x squared y. So x squared into itself. That's 1. So we'd have 1 over y dy. And y into itself. So we have x minus 1 over x squared dx. So this becomes x minus 1 over x squared dx, and this becomes 1 over y dy. So we can now integrate both sides. Notice the left hand side. This is, we can just separate. We can separate this. So this is x over x squared minus 1 over x squared dx equal to integral of 1 over y dy. Now x over x squared, that's 1 over x, right? So that's 1 over x minus, well, 1 over x squared is the same as x to the minus 2, right? Dx over equal to integral of 1 over y dy. So this becomes now, well, let me integrate 1 over y dy. This is just log y. And integrate 1 over x, that's log x. Integrate this, so add 1 to the power. We get negative 1. Divide by a new power, negative 1. This will actually become a positive. Plus or a constant here. So actually, log y is equal to log x plus x to the minus 1 plus c. But remember, we want to solve for y. Right? So therefore, remember, this is actually base e. Alright? Therefore, what's in the bracket here? Y is actually e to everything here, which is log x plus x to the negative 1, or 1 over x, plus our constant, c. And that's that. Now if you want to go further and simplify, I guess we could rewrite this as e to the log x times e to the x minus x to the power of minus 1, which is same as 1 over x, times e to a constant. Alright, so now e to the log x is same as x, and e to a constant will also give another constant. Let me call this constant a, and e times e to the 1 over x. And I guess this is the simplest we can write it. Of course, where a is a constant, and a is a constant, since e to the power of a constant to some power will give us another constant. We just call that a, or whatever you want to call it. So that's it.